All right, this is Honors Algebra 2 Pre-Calculus. We're doing 7.2 in Algebra 2, which is polynomial functions and their graphs. So we learned a little bit about polynomial graphs in 7.1, and we're going to spend some more time talking about them today. The terminology in this section is very important. It's stuff we're going to see a lot of in calculus and moving forward. So when a function rises and falls over an interval from left to right, the function has what's called a local maximum. So see how this function is rising. So let's see how this function is rising here, right? And then at this moment starts falling, because we always read from left to right, okay? That's called a local maximum, okay? When a function is falling first and then starts rising, that point that we have is called a local minimum, right? So sort of the logic of this is that for any interval around this A, right, on both sides of A, any interval around A, f of a is the highest value if something is local max. And it has to be an interval that surrounds a, right? So on both sides of a, to the left and right, is that the highest y value on the entire interval? Same thing here for a minimum. We're looking on any interval around a to the left and right of a. Is that f of a the lowest y value? So, and you can see that down here. So f of a is a local maximum. The plural of maximum is maxima, because it's Latin. You can say maximums, it's in the dictionary, but it's frustrating and grating and awful, so just say maxima. When you want plural maximum values, say maxima. Anyway, if there's an interval around a such that f of a is greater than f of x for all values in that interval, so again, it has to be, again, all values on that open interval surrounding a. So the same thing true with a minimum, we just walked through that. So we're going to walk through a little bit more terminology that you're going to see also in other places. So, all right. So relative is a word that is synonymous with the adjective local, right? So here, sorry, my bad. Here you saw a local maximum and a local minimum. Another way you can say that is relative, right? So what that means is that you are the highest or lowest point in your general area, right? So one way to think about this is that I am the tallest woman in my family, right? I am the local maximum, but I am very short compared to like the rest of the world. So I'm by no means the tallest ever. I'm just the tallest in my local family or my relative area, right? So local and relative. So let's actually jump down here for a second, contrast that with the word absolute, or what you'll hear as global, right? So if I have a graph that looks like this, let's say that's my graph, okay? This would be called a local or relative max because it is the highest point in its immediate area, but it's not the highest point ever. This, being the highest point ever, is what we would call the absolute or global max, right? It is also a local max, because here's the way to think about it. If you're the tallest person in the entire world, you're the absolute max, but you're also definitely the tallest person in your family, right? So relative or local max is a more generic term, right? Absolute max or absolute min means the highest or lowest point that the graph ever hits. Now this graph would have no absolute min, right? This graph would have no absolute min because you can't reach infinity, right? So you can't reach negative infinity, and that's where this graph is going, right? It's going negative infinity, but it does have a local or relative min, right? So that's the idea of the difference between relative and absolute, or you might hear it as local and global, right? So global means everywhere, just like absolute does. So the word extremum is a generic word to refer to either a maximum or a minimum. When your teacher asks you to find the extremum, it's a clever way of me not telling you whether I want you to find a max or a min, right? Extrema is the plural of extremum, so you'll often be asked to find all relative extrema, and that's a way to find all of them and then label them as a maximum or minimum value. Again, this is terminology your book doesn't directly address, but you're definitely going to see them as interchangeable. So some teachers and some textbooks use relative, and some teachers and some textbooks use local. Some teachers and some textbooks use absolute. Some teachers and textbooks use global. I think you're going to see absolute and the most in this case, and then you'll see these two pretty equally. You'll see local and relative pretty equally. You will definitely hear the word extremum or extrema. That's definitely going to happen. So moving on. The points on a graph of a polynomial that correspond to local maxima and local minima are called turning points. Now, I want to point out that in the last video, right, in 7.1, you were told the non-mathy term by your same textbook, right? U-turns. It's the same idea, right? A turning point or a U-turn. When you get to calculus, right? So in AP Calc, you're going to hear these called critical points. So the important piece of information here is that the terminology might change slightly, but as we're moving forward, these values, right, these values where we have local extrema, right, maxes or min values, right, those are going to matter a lot in calculus, in algebra, in pre-calc. We're gonna care about those a lot. So what we call it when a function, sorry, my bad, that wasn't the eraser. What we call it when a function rises, so see how this said rises and then falls? Well, there's an actual math term for rises and falls. The math term for rising is increasing. What it means to be increasing is that each point as your x's increase, right, so as x goes up from x1 to x2, the y values also increase. So what it means to be increasing is as x's increase, the y's also increase, right? So as the x's, as you go to the right, the graph goes up. What it means to be decreasing is as the x's increase, the y's decrease. So basically what we're saying is it's always about moving from left to right. The x values are always increasing. It's what's happening to the y values. So increasing looks like this, decreasing looks like this. And that's going to matter an awful lot when we get to calculus. And you can see there's mathy definitions for it, but essentially what they're saying is for every interval where x sub 1 is the left x value and x sub 2 is the right y value, if your left y value is smaller than your right y value, you're increasing. Well, sure enough, the left y value is smaller than the right y value. Yep, you're increasing. If on that same interval from left to right, your left y value is bigger than your right y value, well, if the left y value is bigger than the right y value, then your graph is getting lower, like it's decreasing, right? So that's the idea behind increasing and decreasing. So we're going to go ahead and graph this function on our calculator. We're going to approximate to the thousandths place, per usual, the coordinates of any local extrema, right? And we're going to label them as max or min. We're also going to identify the intervals on which the function is increasing or decreasing. So let's go ahead and put this in our calculator. So we're going to go ahead and do y equals x to the third plus 3x squared minus x minus 3. All right, let's double check that we put that in right. Cool. And then we're going to go ahead and hit graph. So that's exactly the graph we were expecting, right? And it's a good idea to look at this and say, what graph am I expecting? I expect that this looks like this, and sure enough, it does. So let's go ahead and take a little screenshot so we have this graph, right? All right. So that's what I expect. That's what it looks like. So the first thing I'm asked to do is find the local extrema. The way I'm going to do that is I'm going to do second calc, and I'm going to find the max first. So I'm going to pick 4. I'm going to go to the left of the max. So I watch these y values as they go up, and I see that that's 3.07 is the highest. So far, yep, that's the highest I got. So 3.07 was the highest I got. That's not my answer. The left bound says I then need to go to the left of that. So I just go a couple clicks to the left and hit enter. Now I'm supposed to go to the right. I'm supposed to set a right boundary. So I pass that top point. I go a couple clicks to the right and hit enter. And then for guess, you can literally just hit enter. So here's my max value. And I'm going to go ahead and take a screenshot of that, and we'll deal with these in a sec. So there's my screenshot of my max value, right? I'm going to do the same thing now for the min. So I'm going to go to second calc, right? I want to find the minimum, which is 3. So I'm going to scroll over. I go as far down as I can go, which seems to be the negative 3.06, et cetera, et cetera. So I go a couple clicks to the left, I hit enter. I pass the bottom, I go a couple clicks to the right and hit enter, and then I guess. All right, and see, it tells me that it's a minimum. So I can see that I've done the right thing. I've selected min or max when I was supposed to. So now that's enough information for me to do this entire point. So once I'm here, right, I now have the coordinates of the max and min. So I'm going to go ahead and start answering by saying that A, right, there is a local max at, and then this is approximate, right, negative 2.154 or 5, depending on if you round or truncate, right? That's the x coordinate, comma, and we'll say at approximately so that we're clear, comma 3.079, right? There is a local min at approximately 0.154 or 5, depending on if you round or truncate, and negative 3.079. Okay, so that's the first part, right? It's the first thing I was asked to do, approximate each, which I did, approximate, and label as max or min, which I did. Now I need to identify the intervals of increasing and decreasing. Well, this is actually pretty straightforward, because if you look at this graph, the graph is going uphill until it hits the max, and it's going uphill again after the min, right? So when I want to do part B, which I'm just going to squeeze in here, my graph is increasing on the window from negative infinity until that first x value, which we just found to be this. so to negative 2.154 or 5, right? And again, from the second x value, which was 0.154 or 5, to infinity, right? Ignore that. Okay, and that means that I'm decreasing in the window between them, right? So the decreasing has to be the window between them, so negative 2.154 with a 5 possible if you rounded or truncated, right? And then to a 1.54 or again 5, right? So again, what I did is I used my calculator to second calc max and second calc min. I labeled them as max and min, and I recognized that I'm increasing before the max and after the min, but that my graph is physically going downhill between the two, right? Again, increasing means that you're going up as you move from left to right, and decreasing means that the graph's going down as you move from left to right. All right, let's move on to the next one. So go ahead and give this a try. You're going to do exactly the same thing. You can certainly pause me if you want. So I'm going to go ahead to my y equals. Now, before I graph it, I look at this and I say, oh, I'm expecting a negative cubic, so I'm expecting something that looks like this, right? That's what I expect. Right? It's a good idea to have an expectation in your head of what this should look like. So I'm going to go ahead and second insert because it's easier than typing over there, right? So second insert. And it's a plus 2x squared this time, so I can just type over that 2 plus an x and then plus a 4. All right, I'm going to go ahead and graph. And sure enough, that's exactly what I was expecting. So if you didn't have a calculator, right, if you were really in a pinch and you weren't able to second calc stuff, you could at least get the argument that you understand from what you're expecting, that you're looking for a graph that is decreasing here, increasing in the middle, and decreasing again at the end, right? I have a min here, I have a max here. So I'm going to go ahead and second calc min and second calc max to find those values. So second calc 3 is min, right? So I'm going to see what the lowest value I can get to is, right? It seems like the lowest I can get is this 3.88 stuff. So I'm going to go a couple clicks to the left and hit enter. I'm going to pass the 3.88 again, couple clicks to the right, hit enter, and then guess. So there's my min, right? I'm going to just take a quick screenshot because that seems like the easiest option, right? There's my min, right? And then we'll do the same thing. So we're going to second calc, and we want max, which is 4. So again, I'm going to scroll over till I think I'm at the highest point I can get to. Seems like the 6.62 is the highest I can get. So a couple clicks to the left, because it says left boundary. And see there's also an arrow that points you in the right direction. A couple clicks to the right, so I pass the 6.62, enter, and then hit enter again. I'll take a screenshot, and there's my max. So I have my min, I have my max, right? And so now I can pretty much answer all of the questions from that set of information, right? So here's what I get for A, right? I know that there is a local min at approximately, and then we can go ahead and find the local min coordinates, right? It's this. So negative 0.215, comma 3.887, right? That's the best we've got. There's a local max at approximately, and then we use these coordinates, so 1.548 or 9, depending on if you round or truncate, and 6.631, right? And then when I look at my graph, I say, oh, it's decreasing on the two ends. So when I answer B, my function is decreasing on the interval from negative infinity to the first x coordinate, which was the negative 0.215, right? And again, on the second interval, which would be the 1.548 or 9, right, to infinity. And I see that my graph is increasing on the window between them. Right, and there we have it. Okay, so let's go ahead and keep moving on, right? So use your calculator to approximate all relative extrema to the thousandths place on the closed interval, and that's going to be relevant. So let's walk through this. So I know what I'm expecting, right? I look at this, I see this, and I say, cool, I'm expecting this kind of graph, but it's a closed interval, so I'm not expecting arrows, I'm expecting endpoints, right? So let's go ahead and put our y equals in, right? So we have this x cubed, right? And it's minus a 4x. Cool. So let's go ahead and graph. All right, so there's my graph. Now what I want to point out is that we actually can't see the value at negative 8 and 8, but we'll deal with that in a sec. So when I look at this graph, right, since it's a closed interval, there's a minimum here. There's also a minimum here. There's a maximum here. there's also a maximum here, right? Those are both the highest values around. So little hills, right? Hills are maxes and valleys are mins, but closed endpoints can also be a max or a min, right? And so in this case, I do have both local, like I have a local min at the endpoint and also a local minimum here. I have a local max at the endpoint and also a local max at the hill. So I'm going to go ahead and use my calculator to find the two values. So I'm going to use my calculator to find this one and this one, right? So I'm going to use the calculator, right, with second calc min, second calc max. So when I do that, second calc, I'm going to go ahead and do the max first because I usually work from left to right. So I'm going to go over here. I'm going to pass what I think the top is. Enter. I go past the top. Enter, and then I guess, right? So there's 1, right? So there's a local max, right? Then I'm going to do second calc min, right? I'm going to go close to where I think the minimum is. I'm still to the left of it. I'm going to pass the minimum, so now I'm to the right of it, and then I guess, and there's my min. Okay, so I found those two. But the other issue, so let's go ahead and drag those over now, right? I found this one, and I found this one, right? But since it's a closed interval, I also have to find the physical y values of those spots. So I'm going to hit trace. I'm going to hit 8 and see what happens. Hey, look, it did it for me. So when I hit 8, I got a value at 480. And when I hit trace and -8, I'm going to get a value that's -480. So if we go ahead and put both of those here. So again, you don't have to plug in the number. You can definitely use your calculator to find that number for you. So what I realize is that, so there's two local maxes, right? So this is a max, and this one up here, this is a max way up here. So there's a max way up there at x is 8, right? And this one down at -8, we can see it's a min. So when I give the answer to my question, I'm going to have a local min at two places. I'm going to have one at -8, -480. And I'm going to have one right here at approximately 1.15, sorry, my bad. At approximately 1.154 or 5, comma, oh, I did not give myself enough space. That's unfortunate. So, so there's one there. There's one at 1.154 or 5, depending on if you're under truncate, and -3.079, right? There are local maxes, right, or local maxima at 8, 480, and also at approximately this thing, which is the -1.5, sorry, -1.154. I can't do this to save my life today, comma, 3.079. All right, so I have two local max values, two local min values because it is a closed interval. So that's important that it's a closed interval. All right, so you're going to go ahead and try a P2 the same way. Notice that it is a closed interval, right? So it's helpful to know what you're expecting because if you know what you're expecting, you can kind of ahead of time think, hey, this is probably a W, right, with closed endpoints. So it's a pretty safe guess that these are both max values. If there are two parts to the W, there would be mins, and this little guy would also be a max, right? So let's go ahead and see what we have when we graph, right? So I'm going to get an x to the 4th minus a 2x squared plus a 2. Go ahead and graph. Hey, there we go. And that's pretty much exactly what I was expecting, right? So there's a couple different ways I can do this, right? I can just go ahead and, knowing that this is what this looks like, I can say, hey, I've got a local max at the following spots, right? I know I have one here at -5, comma blank, which we can figure out in a sec. I've got one at 5, comma blank. Those are the two endpoints. And then I have one at whatever this middle spot is, right? I can also do the same thing where I say, that's not how you spell local. I can say that I have a local min at whatever these two spots are here, right? And both of those are going to end up having to be approximated. So, so that's my local maxes, and I have local mins at these two approximate points, right? And I can go ahead and find them on my calculator. So I'm going to go ahead and do second calc. Let's go ahead and get we'll work left to right like you usually do, so we'll do that first min, right? So I go past what I think the minimum is, a couple clicks, I hit enter. I go past it again to go to the right, I hit enter, and then I guess. And I can either put, so I really should put -1000, right? And then 1. You could just put -1 because it depends on how accurate your calculator is. Some of you, your calculator is going to come up with -1 here. Some of you, your calculator is not going to come up with it. And it sometimes depends on how accurate the points are that you pick, but that it is what it is. So now I'm going to second calc max because, again, me personally, I like to work left to right. So I'm just to the left of the max. I cross the max, and then I hit enter, right? Now this is a 0 because what this means, so this is 0, comma 2. The reason I want to point that out is 7.6837e negative 7 means a 7.6837 times 10 to the negative 7th, which means move this 7 places. So that would be, here's my 0.7s, here's my 7.6837, right? Ready? 1, 2, 3, 4, 5, 6, 7. Yikes, that's definitely a 0, right? So I just want to point out that that's definitely a 0, okay? And so then I find the last one, right? Second calc min, right? I scroll over, couple clicks to the left, pass the min, enter, and enter. And this one gives me 0.9991, or if you rounded, this would be 1.000. So again, depending on how accurate your choice is, you might just get a 1 there. The last thing I need to do is find the y values of these two, right? So when I find the y values of these two, I'm just going to hit trace, right, and -5. And I'm going to get that this is a very large number, 577, right? And I'm going to hit trace and regular 5, and I'm also going to get a 577. Right, so those are my answers, and I didn't need all of this space because my approximation didn't turn out to be all that big, right? So I could have just written it as 0, 2. So this is 0, 2, right? And same thing here. I didn't need all that space. All right, cool. So we're going to stop in this video, and then we'll do our next video in a sec.